Welcome to our series on differentiation. We are using the power rule to find the gradient function and then analyzing for it to be a maximum or a minimum. Enjoy the journey of learning. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss about turning points, which are also called stationary points, for the function f of x equals to 2x cubed minus 2x squared minus 3. We need to find the exact coordinates of the stationary points on the graph of f of x. And then we need to determine the nature of turning points using second derivative. Well, when we say nature of turning points, it could be a maximum, it could be a minimum, it could even be a saddle point, a point of inflection. We can use second derivative and we can also use first derivative. But in this case, we'll analyze using second derivative. Now, let us see how do we solve such a problem. We are given the function f of x, which is 2x cubed minus 2x squared minus 3. To find the stationary point, we need to find the gradient function, which is basically the derivative, right? So f prime x, which is the derivative, will be what? We are going to use power rule. So if the function f of x is a x to the power of n, then the derivative of the function is you multiply with n, which is n times a, right? And in the exponent, reduce by 1, so n minus 1, right? So times it with the coefficient, the index n, and also reduce the index by 1. That is the power rule. So this is called power rule for derivatives. So in polynomials, we just apply power rule. So applying the rule, 2 times 3 gives us 6. And when you subtract 1 from 3, you get square, 2. Here, 2 times 2 is 4, and x to the power of 2 minus 1, which gives me 1, so that means x. A constant means x to the power of 0, so the derivative is 0, right? So we get the derivative. Now, to find stationary points, what are stationary points? Well, stationary points are the points where the derivative of the function is equal to 0, right? So that is stationary point. Clear? So let's equate this to 0. That is to say, 6x squared minus 4x equals to 0. To find the value of x, good to factor them. So 2x is common. So we get 3x minus 2 equals to 0. So that gives us two values of x, right? One of them is 2x equals to 0, which gives us x equals to 0. The other one is 3x minus 2 equal to 0, which gives us x equals to 2 divided by 3. Clear? So basically, we'll end up with 2 points. Now, we need to figure out whether these are the turning points or not. Sometimes they may not be a turning point also, right? And we have to use the second derivative to figure this out. But the first part also indicates find the exact coordinate of stationary points. So to find the coordinates, we'll find the value. So at x equals to 0, just substitute 0 here. What do you get in the equation? You get 0 minus 0 minus 3, or f of 0 is indeed minus 3. So one of the stationary points is 0 minus 3. Is that clear to you? The other one, I'll substitute 2 by 3. So find the value of f of 2 by 3. Slightly complicated. 2 times 2 by 3 cube, right? Minus 2 times 2 by 3 square, right? And then minus 3, right? So that's what it is. We can actually take it on the next page. So for f of 2 by 3, let's recalculate. So we get 2 times 2 by 3 whole cube minus 2 times 2 by 3 whole square minus 3, right? So it becomes 2 times 2 cube is 8 and 3 cube is 27 minus 2 times 2 square is 4 and 3 square is 9 minus 3. So we can have 27 as a common denominator. So the numerator here is 16 minus. We have to multiply these by 3. So 4 times 2, 8. 8 times 3, 24. Minus 27 times 3. So 3 times 7, 21. 2. 3 times 2, 6 and 2, 81. Right? So that gives you, so we can now take away 16 from minus 27 minus 81. Right? So basically it is equal to, we can do 16 minus, add them first, right? So we get 105 over 27, which is of course negative, and 15 take away 6 is 9, and 91 take away is 89 over 27. So we get 89 over 27 as a point F23. Is that clear to you, right? So we get both the points. So we get one point, let's call that as A at 0 was minus 3, and the point B at 2 by 3 is minus 89 over 7. Is that clear to you? Well, if the calculator is allowed, it is a much simpler job. So we got this part. Now the question is to verify using second derivative, correct? So second derivative. So let's find the second derivative. So the function was given to us as 2x cubed. I'll just redo it. Minus 2x squared minus 3. The first derivative is 6x squared minus 4x. Second derivative is derivative of the derivative, right? Not an issue. The second derivative will be 6 times 2, just multiply again, x minus 4. So that becomes the second derivative. Now, how do we verify whether this point is a maximum or a minimum or neither, right? Now, important concept is that if the second derivative, let me write down the concept first. If the second derivative is greater than 0, think like a parabola, right? So we have a minimum, right? And if the second derivative is less than 0, it will be like a parabola opening down, it will be a maximum. Is that clear to you? So that is the concept, right? So we just find second derivative and then plug in the value of x. So let's do that part. So f of second derivative at 0 will be 0 minus 4. So it is less than 0, right? Since it is less than 0, as you see, this will result into maximum. And therefore, what we notice here is that point A, which is 0 minus 3, will be a maximum. Is that clear to you? Now, let's plug in the second derivative equation, which is a function, of course, 2 by 3 now, right? So, 12 times 2 by 3 minus 4. So, that means 4 times 2, 8. So, it is greater than 0, right? So, since it is greater than 0, it is a minimum. Get the idea? So we get a result here that we have a maximum at 0 minus 3. So let me write down here. So we have a maximum at 0 minus 3 and minimum add 2 by 3. The values are also calculated. Correct? I like you to check the values uh, on your own, right? So basically, let's summarize the strategy here. So what we did was that we first found the derivative of the function. Function given to us was 2x cubed minus 2x squared minus 3. So best way is find the derivative, which 6x squared minus 4x, and also the second derivative. You get the idea, right? So we get 12x minus 4. Now, once you find the derivatives, we should find the critical numbers. These are also called stationary points, right? Which really means that we'll equate the derivative to 0. So if you equate this derivative to 0, which is this equation, right, we get 16, 6x squared minus 4x equals to 0. Always factor. So you get 3x, sorry, 2x is the common factor as we did, right? 3x minus 2, and that gives you two zeros, correct? So x equals to 0 and x equals to 2 by 3, correct? So once you find these points, then basically you have to plug in here, right, in the second derivative. So let me call the point as a and b, right? So if I plug in a, and if it is greater than 0, that means it represents a minimum. And if I enter a point, let's say b, and if it is less than 0, then think like this, it represents a maximum. Perfect. So we found these points. You can always plug it in and verify whether at that particular x value we have a minimum or a maximum. And then, of course, you find the two values, right, which we did, and get your answer. So I hope the whole concept is absolutely clear. Feel free to write a comment, share your views. In case you want to learn from me, our students are doing extremely well, by the way, then send an email on globalmathinstitute@gmail.com. We can be part of your success. Thanks for your time and all the best.